Hello, Professor Guo. It is our pleasure to invite you for this OJAP talk. First of all, thanks very much for your contribution to our OJAP Special Section on advanced antenna technologies for 5G Internet of Things applications. Your paper is about antenna technologies for 6G systems. Currently, 5G systems are still being rolled out worldwide. Can you please share with us your thoughts about the major differences of 6G systems compared with 5G and the anticipated applications of 6G systems?
Thank you very much, Lin. First of all, I would like to express my thanks to the OJAP or OJAP editorial board for inviting me to the OJAP talk. It's a great honor and privilege for me. 5G technology has been focused on massive connectivity to cater for IoT, low latency for time-critical applications, and greater data rates for hotspots using millimeter wave technologies. This is kind of different from 5G, from 6G. The vision of 6G is still being formulated. The requirements for 6G, which are prerequisites for any standardization activities, are still being discussed. Therefore, nothing is 100% certain at this stage. However, most pioneers or researchers at the moment point in the direction of the following. Firstly, ubiquitous coverage for everyone and everywhere, on land, sea, and in the air. This is important for regional and remote communities and also for many industries, such as logistics and resources. So just to name a couple. So the second feature would be great intelligence level for network management, radio resources management, and content management. This is really to take advantage of the latest development in the artificial intelligence and the big data technologies. The third feature of 6G probably will be greater security and privacy. Greater connectivity necessarily means potentially greater security risks and privacy violations. We absolutely need greater security and privacy in order to enable the applications envisaged for 6G. Last but not the least, cost efficiency. We have to develop low-cost solutions to make 6G affordable to both network operators and end users. Now my answer to your last point. What will be the main application for 6G? Well, the so-called killer apps. These are the hallmark applications for each generation of mobile communications networks have always been a great discussion point. Unfortunately, the industry and the research community do not have great track records in making predictions in the past. For your information, or those of the young listeners, I was in the discussion of 3G in the early days. A main discussion point on application of 3G back then was about tracking pets, such as cats and dogs. This was, of course, far off the mark and never became a killer app. So for now, application for supporting industries I mentioned earlier, that is logistics, resources, agriculture, etc. And the real-time digital twins are quite good candidates for 6G applications to my mind. Thank you.
Thanks very much, Professor Guo. So your paper in the special section particularly emphasized the millimeter wave, terahertz, multi-beam, and quasi-optical antenna systems. So why do you feel they are among the major features of the future, we call it beyond 5G or 6G wireless systems?
Well, to my mind, as far as antennas and RF circuits are concerned, dynamic multi-beams at both the base station level and the terminal level will become very important for anticipated connectivity in 6G. Actually, the distinction between base stations and terminals for certain parts of 6G network may disappear. Therefore, analog multi-beam antenna solutions have great potential to increase the cost efficiency of 6G, which was the fourth point I mentioned earlier. Therefore, actually my keywords are analog multiple beams. So why using quasi-optical systems? Our OJAP paper is actually a sequel or twin paper to what we just published in OJAP's sister journal, IEEE Journal of Microwave, JMW for short. In the JMW paper, we presented the review and our vision on circuit type beamformers for lower frequencies, that is millimeter or microwave frequencies. This OJAP paper is targeted at higher frequencies. It's important to remember that microwave frequencies are indispensable for wide coverage, especially on the land. Higher millimeter wave and terahertz systems are greater for delivering super high data rates, which will be terabits per second for 6G. However, because of the propagation losses, higher frequency systems, such as terahertz one, are probably only suited for hotspots and local connections on the land or communications in the space. So in short, both quasi-optical systems and circuit type systems will be important. Thank you.
My next question is, you have mentioned both the wireless systems in space as well as the integrated terrestrial and the non-terrestrial networks in general. So why do you think their integration is important for 6G? So what new issues do you anticipate for both antenna and propagation aspects to enable the integrated space and the terrestrial networks?
The integrated terrestrial and the space networks will be critical to realize the ubiquitous coverage 6G is supposed to provide. Actually, it's extremely hard for me to imagine any other solutions to provide such kind of coverage. For antenna experts, we need to study those quasi-optical systems to deliver compact and cost-effective solutions for space communications and for the integrated land and space or terrestrial, non-terrestrial networks. This was the very reason we wrote the OJAP paper. For propagation actors, which I'm not, we probably need to develop new channel models for the new environments 6G will be operated on the sea in areas communication coverage has been very, very patchy to say the least, such as Antarctic.
You have addressed several research challenges associated with the multi-beam, millimeter wave, and terahertz antennas for 6G in the paper. And you also suggest that combining lens and reflectors with digital beamforming to form a hybrid arrays is potentially a viable solution. Can you please elaborate on this point?
Thank you. That is a very interesting question and might deserve a very long answer, but we do not have a lot of time. So I'll try to give you a brief answer. So hybrid antenna arrays are a new technology my team pioneered since more than a decade ago. And we have been publishing a lot of papers in various journals, including wireless communication, signal processing, vehicle technologies, etc. It became a very important technology, actually critical one, for 5G implementation due to its low cost advantage. The essence of the hybrid antenna array is to process the signals jointly in both the analog domain and the digital domain. I can give you some simple examples. The first example is to have a digital beamformer as a feed to a lens or reflector. So that's very simple. A little bit more complicated example would be to have a number of lenses connected in a digital manner. So the signal processing happens in the digital domain, whereas the beamforming happened in both analog domain and the digital domain. This way, we have both the antenna gain, one may need, and the beam steering functionality. The essence of hybrid beam forming is really to take advantage of both ends, analog and digital, to realize the performance requirements, also to keep the cost low. Thank you. I hope that makes sense to you.
Yes, I know you have a quite unique career path. You have worked in several telecom companies in the UK, as well as an Australian government research institute, CSIRO, and now at the #1 young university in Australia, the UTS. So what experiences would you like to share with us, in particular for young IEEE members to consider in their choice of career paths among the academic, government, and commercial opportunities?
Thank you. To start with, I do not want to advise anyone to just move across different continents and changing jobs or every few years. It has been fun, but also been hard, especially hard on my family. So I thank them for their support. But anyhow, during the process, I did learn some great lessons. The first thing I would say is that my experience tells me that deep technology development requires in-depth understanding of science and engineering. Therefore, spending serious time doing research, such as pursuing a PhD, would be very important for anyone who are interested in becoming a great engineer or a technologist. So on the other hand, without solid understanding of practical systems, such as communication systems, sensing systems, IoT, etc., one can easily miss the big picture stuff. So you might end up spending a lot of time solving problems which can be easily solved in other parts of the whole system. So therefore, I would also recommend young academic researchers to have serious interactions and engagement with industry, if not working for them for a period of time. Thank you.
Thanks for your suggestions. My last question is, I understand you have 2 books in the works related to antenna array engineering for 6G wireless communications. Can you please share some of the details with the audience?
Yes, actually, this one of the few good things would happen during the COVID lockdown. So when we were locked down at home, we have more time to write and think. So fortunately, Professor Richard Ziolkowski and myself are in the process of having 2 antenna books published very soon. They are all related to future wireless communications and sensing systems. We should have the first book published in the next few weeks. The book is entitled Advanced Antenna Array Engineering for 6G and Beyond Wireless Communications. The book aims to cover topics which are important to beyond 5G and 6G systems, but have not been covered in any other books. Specific topics include 5G antenna requirements, 6G antenna candidates, multi-beam forming networks, decoupling and descattering in collocated antenna arrays, which will happen more and more with more generation systems being deployed, and conformal transmitter arrays for airborne platform, fixed frequency beam scanning using leaky wave structures, as well as strategies for synthesizing analog arrays. So there are lots of topics which will be important for 6G even beyond. So the second book is entitled Antenna and Array Technologies for Future Wireless Ecosystems. Now we ran out of G, so we talk about future wireless ecosystem is that. The book will be published later this year, we hope, because the manuscript is largely ready to be submitted. So this second book is an edited book with contributions from both us also more importantly, many top experts around the world. It covers many issues important to 5G, 6G, and the future systems. These include, for example, antenna packaging, terahertz antennas, beamforming using modulated metal surfaces, and quantum antennas. So as the quantum antenna name suggests, it won't be part of 6G, might be part of 7G or even 8G. Let's see. So I hope these books are valuable addition to the antenna literature. So to everyone yourself, happy reading. Thank you.
Thank you, Professor Groys. It looks a very interesting book, and we look forward to have your book in hand in the near future. Thanks again to join the OJAP talk. Good evening.
Thank you. It has been a pleasure to discuss with you. All the best.